Right, so after watching the previous video, you should be able to, get some sense of how these equations come from. You don't really need to completely understand this, but just feel the flow of how those equations comes from. Then you'll be more confident when using those equations to calculate and answer the questions on your assignment. So in the previous video, we're deriving those equations from a simple motion without projection height. How about with projection height? The equation will be the same. Like without projection height, h will be 0, which makes the equation a little bit simpler. Also, 0 here would make the whole thing a little bit simpler. But adding it projection height will make the equation look a little bit more disgusting, but the basic concept is the same. So to explain this, we're going to think about start from the maximum height, because that's, I think, it's an easier way to teach this. So we know the maximum height would be this equation. We've derived the first thing in previous video. Where does that h come from? The maximum height we derive with this equation would be the height from the apex to here, like the height when the ball was released. And when there is a projection height, you just need to add h to it. So you got a total maximum height from the ground. So that's how we get this equation. The thing without projection height plus projection height. All right, so think about now we're trying to get the velocity at this end, which will make this the process simpler, I think. So that's how I think about this process. I want to get the velocity at the end here. So think about after reaching apex, so from here to here. On the vertical direction, it's actually a free fall. And the falling distance will be maximum height that you've already had here. Alright, so that's how we're going to calculate it. We're trying to get a velocity here. So we're going to use this equation. We want to get a final velocity. And the initial velocity would be 0. That travels from here to here, right? Initial velocity equals to 0 plus 2 times gravity, which is acceleration, times d, which is the total vertical distance that a ball needs to travel. And you can get a total distance from this equation, the maximum height. So now you get a final velocity here, which is square root 2g times maximum height. And when you put the equation into it, you get this thing, vi sine theta squared plus 2gh. Okay, why do we want to get the final velocity? This is the equation for total flight time with projection height. Think about the first thing, the red circle, vi sine theta divided by g. Right? Vi sine theta is the velocity right here from the beginning. So that means how long the gravity can take this velocity to 0. So that's the time from here to here. And how about this blue one? We know the denominator is the same as what we just have, right? Vf, the velocity here, square root vi sine theta squared plus 2gh. Square root vi sine theta squared plus 2gh. So that's actually the Vf, the final velocity here. And divide by g, what does that mean? That means how long it takes from this point to get to this point. So that's the total flying time. And when we separate the entire motion with the apex, we know the first half time will be vi sine theta divided by g. The second half, a longer one, will be the whole thing in the square root divided by g, because that's the final velocity divided by g. That's how long it takes to complete this motion, and how long it takes to complete the first half of the motion. So that's where the total flight time with projection height comes from. And then the same concept, range equals to horizontal velocity times time, right? And the horizontal velocity won't change. You just use that to multiply by time. So the same, you got v cosine theta times total flight time. You get a range like this. All right, so the concept for range is the same. All right, so that's how we get those equations in both with and without projection height. So when you're trying to use those equations, make sure you understand which type of projectile motion are you analyzing. For example, in the golf chip shot, the golf was on the floor, right? So it's the simple one without projection height. So you can just make h0 and the entire equation will be a lot simpler. But how about for football pond? There is a projection height. So you need to use a more complicated equation. But the basic concepts are the same. So when you're choosing the equation, make sure you understand which motion is it. Alright, and we'll talk about the assignment in next video.